First one, find Laplace transform of xt equal to delta t, where delta t is an impulse function, and also find its ROC. Xs equal to, you already know from the formula, xt e to the power minus st dt. Substituting xt as delta t in this equation, I'll get minus infinity to infinity delta t e to the power minus st dt. This is equal to 1. That means my xs is equal to 1. Now by looking xs, we can find ROC as full S plane. Because for any value of S, xs is always 1. Second, find Laplace transform of xt equal to t minus 1 whole square u of t minus 1. Again, same thing, use the same formula, substitute xt, infinity xt e to the power minus st dt. I am having minus infinity to infinity t minus 1 whole square u of t minus 1 e to the power minus st dt. I can write it like this: 1 to infinity t minus 1 whole square e to the power minus st dt. Okay. Now I'll substitute t minus 1 equal to m, which will give me dt equal to dm. So my limits will become 0 to infinity m square t equals to m plus 1 e to the power minus s m plus 1 dm. On solving this integral, xs equals to e to the power minus s upon s cube. So this is a simple, actually finding Laplace transform is nothing, it's just looking like a simple integration calculation. It is nothing more than that. Definite integral calculation is the way to find the Laplace transform. Again, a different type of problem. In this, a figure is given, and from that figure we have to find the Laplace transform. Find Laplace transform of above figure. Again, x is equal to minus infinity to infinity xt e to the power minus st dt is equal to, now we have to substitute between the two limits. One limit, the equation of xt between minus 2 and 0, another limit between 0 and 2. So I'll write it as like this: minus 2 to 0 x1t e to the power minus st dt plus 0 to 2 x2t e to the power minus st dt. Okay, now we have to find the x1t and x2t. Use the formula for the equation of line. I'll get something like this: x1t minus x1t minus 0 equal to 1 minus 0 upon 0 minus minus 2 t plus 2. This implies that x1t is equal to 1 upon 2 to t plus 2. Similarly, we can find x2t. Substituting x1t we will get so whenever any figure like thing is given for xt, we have to find the equation of the various parts of the figure and substitute those equations by taking the proper limit within that range, in the range in which the equation is valid, and we have to solve the integral. So again, this is a simple thing, just we have to take the equation of the different parts of the figure. Okay, now another variety of problem in which Laplace transform is given and region of convergence is given. We have to find the inverse Laplace transform of that. If xs is equal to 2s plus 4 upon s square plus 4s plus 3, where ROC is in between minus 3 comma minus 1. Now we have seen that ROC is lying between minus 3 and minus 1. We can see from the ROC pattern, it is neither including j omega axis nor it is outside the outermost pole. So in the given question we have to find xt. So now the xt whatever we will get, that will neither be a causal nor it will be stable. Okay, that is not a problem, but we have to find the xt out of that for the given ROC. Now partial fraction of xs will give me 1 upon s plus 1 plus 1 upon s plus 3. Okay. Now ROC is right side the pole for minus 3 and left side the pole of minus 1. That means xt will be equal to minus e to the power minus t u of minus t plus e to the power minus 3t ut. So this is the case with, this is the inverse Laplace transform of xs for the given region of convergence. Okay. Another different variety of problem in which relationship between xt and xs is given. Sin 3t ut gives me Laplace transform as xs. Now, if ys is certain Laplace transform related to xs as ys is equal to s square plus s into xs, then the corresponding time domain function yt will be here. We have seen that ys equal to s square plus s into xs. Okay. Now we have to open the brackets and see that ys can be written as s square into xs plus s into xs. That means it is looking like that if xt has Laplace transform xs, then dy dt of xt will have Laplace transform xss. Similarly, d square by dt square xt will have Laplace transform s square into xs. Thus, yt is equal to d square by dt square xt plus d by dt of xt, which is equal to d square by dt square sin 3t plus d by dt of sin 3t. So this is equal to d. We have to find the differentiation of sin 3t. This is equal to minus 9 sin 3t plus 3 cos 3t. Another variety of problem in which input and output are related by some differential d square yt by dt square plus dy by dt minus 20 yt is equal to minus 2xt plus 5 times of dxt by dt. For this, I have to find the impulse response. Now, we have to use the differentiation property of the Laplace transform to convert this differentiation term into a multiplication and division term. Okay, I can substitute d square yt by dt square equal to s square into ys. dy by dt is equal to s into ys. dxt by dt is equal to s into xs. Thus, above equation can be written in the form of Laplace equation as s square ys plus sys minus 20 ys equal to minus 2 xs plus 5 into s xs. This implies that ys upon xs is equal to ys upon xs is equal to 5s minus 2 upon s square plus s minus 20. Now for this equation 1 we have to find inverse Laplace transform. Now I can write it as like this: ys upon xs is equal to 3 upon s plus 5 plus 2 upon s minus 4. Okay, this will give me the way to find the Laplace transform. Now after reaching here, we have to see whether the given system is causal or stable, or it is non-causal, or it is for unstable system, or whatever the condition given. Now assuming that system is causal system, we have ys upon xs equal to hs Laplace transform as ht equal to 3 times of e to the power minus 5t ut plus 2 times of e to the power 4t ut. In case it is stable system, then ht is equal to 3 times of e to the power minus 5t ut minus 2 times of e to the power 40 u of minus t. So depending on whether it's given as a stable or it is a causal, we have to write the equation for the inverse Laplace transform. These equations are generally found using the general expression for the Laplace transform. So for finding these inverse Laplace transform easily, we should able to know what are the Laplace transform generally for e to the power 80, e to the power minus 80, for t ut and for t square ut and other general form of Laplace transform. Okay. Now solve these questions. If xs equal to s plus 1 upon s square plus 3s plus 2, then xt is question mark. If xs is equal to s plus 2 upon square plus 2s plus 10, then xt is question mark. If xt ut is given as 3s upon s plus 2, then ys equal to question mark if yt is equal to xt convolve with d by dt of xt. Solve these questions.